All right, Math 2, Unit 6, similar triangles. So numbers 1, 2, and 3 here, these are different ways that we can prove that triangles are similar. And I typed them in, that way you don't have to read my handwriting, but let's just look at them all. So side-side-side similarity. If two triangles have proportional corresponding sides, then the triangles are similar. So if you remember, whenever we talked about general similar shapes, not just triangles, but all similar shapes, we had to check the angles and the sides. This is telling us that for triangles, it's special. You could just check the sides. You don't have to know that the angles are proportional, or are congruent, rather. All right, number 2. Again, this is a shortcut to our normal similarity rules. If two triangles have two pairs of proportional corresponding sides, with congruent included angles, the triangles are similar. And now what they're talking about here are two triangles where you know that, like, we'll say those are A, B, C, D. You know that A over B equals C over D, right? You know that you have a proportion there. And the angle between them is congruent. That's what that means. And then number 3 means that is angle-angle similarity. If two triangles have two pairs of congruent corresponding angles, then they're similar, right? Really, number 3 is like angle, but we know that if we know two of the triangle's angles, we could find the third one really easily. So you don't really need the third one. So number 3 and number 1 are kind of like half and half of the normal similarity rules. Number 1 deals with the sides, and number 3 deals with just the angles. And then number 2 is kind of a mix of both. All right, let's see how we can apply them. State if the triangles in each pair are similar, and if so, state how you know they are similar, and complete the similarity statement. So for starters, state if they're similar, so that's going to be like the yes, no. If so, state how you know they are similar. That's going to be using one of these 3 rules up here. And then complete the similarity statement. That's going to be this thing here, and I'll get to that in just a second. So for starters, we need to figure out, are these two triangles similar? They don't give us any side lengths, so we're going to hope that we could use number 3 here, angle-angle similarity. So the way that I normally do this, and maybe this will help you too, is I put different shapes. I mean, on my iPad here, I'm able to change colors, but for you, whenever you're using just a pencil, you can put different shapes. So I would normally like circle the 47s and then put little boxes around the 76s. That way it kind of helps me in my mind know how to change the triangle, how I have to like kind of rotate it there, and then I can kind of see how they would line up. So we do have two pair of congruent angles so that it is similar by angle, angle. Now for the similarity statement. So they say here triangle WVU, that's talking about this bottom one here. And then this little symbol there means is similar. And then we're going to say it's similar to triangle. Well, it's similar to the top triangle, but we have to name it in a special way. The order of the points here matters. So in the first triangle similarity statement, W is first. For the second one, we need to do this. The point that corresponds to W needs to go first. So W has an angle of 47. Up here, C has an angle of 47. So for starters here, we're going to have to put a C. And then we have V, and V goes to 76, so D. And then the only one left over is E. So that's how we do that. Let's look at number 5. So number 5 here, we have two sides given on each of the triangles, but they're written in this funky way where they overlap a little bit. And we're actually going to have to use an old rule that we hopefully remember. Remember that if we have two lines that intersect, there are vertical angles in this intersection, right here and right here, or right here and right here. and they're congruent. So in number 5, we could say that this here and this here is congruent. So now we have two sides and the inside angle, or what do they call it? The intersecting angle? Included angle. Two sides and the included angle. So now we need to see, are these sides proportional? So first, I'm going to grab the smaller sides. I'm going to put a circle around the smaller side for both triangle. So this upper right triangle here has a 5 and a 3. I'm going to put a little circle around the 3. That's the smaller one. And then the other one has 18 and 30. 18 is the smaller one. So I want to know, is 3 over 18 equal to 5 over 30? This is 1 over 6, and this is also 1 over 6. So yes, they are proportional. So we could say, well, yeah, these are similar. How did I write it last time? I think I said, oh, well, there's how CUDA will write it. They'll say similar, and then they'll say side angle, side similarity. And then here it wrote our answer, but I want to work through it again. So in our similarity statement here, we have TSR, and almost all the time, if the triangles overlap on a point, the point is going to be the same order in both similarity statements. They don't always have to be that way, but that's normally a good guess. Still, you need to check yourself, but that's a good guess. So triangle TSR, we're going to start off with triangle T, and then S, well, if we look up here, T to S is along the long side, so we're going to do T to V, and then R and U. R goes along the short side here, so we're going to go along the short side there. And that's that. All right, number 6. Number 6, we see no angles listed. So we're going to hope that side, side, side number 1 works. So let's find the shortest sides here. We've got, on the top one, the shortest side is 16, and the bottom one, the shortest side is 4. On the top, the next smallest is 28, and it goes with 7. And then we have 32 and 8. And the only reason I do that right there is so that I know which one goes with which. So we'll see 4 over 16, and we want to know, is that equal to, we'll do the blue ones next, 7 over 28, and then we want to know, is that equal to 8 over 32? Well, this is 1 over 4, this is 1 over 4, and this is 1 over 4. So yes, it is similar. Similar by side, side, side. And now for our similarity statement, we start off with triangle D. So we have the point D there. D is between the orange and the blue side. So up top, I'm going to go between the orange and the blue side. And look at that, they actually labeled it with the same letter. So we're going to have triangle D. And then E is between the orange and the green. So between the green and the orange is going to be U. And then the last one left over is V. All right, number 7. We have some different angles listed in here. R and G would go together. F doesn't have a partner. P doesn't have a partner, and Q doesn't have a partner. So these triangles, we're going to say, are not similar. All right, so number 7 is not similar. All right, let's look at number 8. Solve for x. The triangles in each pair are similar. So it's not a question, are they similar? We are told they are similar. So we have some sides here, and we need to find x down here. So we know the whole side is 7x minus 6. What we're going to do here is we're going to write some proportions of the sides, and then we're going to be able to solve for x. So we can see that triangle EFG, so I'm going to do little different shapes here. E, circle. F, I'm going to put a box. And then G, I'll put a triangle around it. And then L, circle. J, or K, box. And J, triangle. And you can double check yourself. They should be circle, box, triangle. Circle, box, triangle. And again, me doing that just helps me to know where do things go. So my 7x minus 6 is between the circle and the triangle. The other thing that's between the circle and the triangle is 30. And then we can say the same thing about 54 and 45. 54 is between the circle and the box. 45 is between the circle and the box. I don't know. If you're able to just read that from the similarity statement, that's great. I need a little bit of help doing it this way. So now I write my proportions. And what I normally do is I grab the whatever has the x and I put that on top, because I think whenever I solve it, it's easier if the x is on top. So I'm going to start off with 7x minus 6, and then I put its corresponding side length. So I'm going to put 30. And then I know that is equal because they are similar. And then I have to go back to my original triangle. So see that the 7x minus 6 goes with the bottom triangle. So I need to have 54 on top also, because 54 goes with the bottom triangle. And then 45. To me, that's the hardest part of the problem. Now we just have to do the algebra to solve. So I will multiply by 30 on both sides. That cancels those guys out. So I'm left with 7x minus 6 equals, and let me type that in. I've got 54 divided by 45 times 30. That is 36. I add my 6 over, I get 7x equals, what is that, 42. And then x equals, what's that going to be? If I divide by 7, I get 6. So there's my x. X equals 6. All right, number 9. This one works a whole lot similar, very similar. I'm going to start off doing the same thing. I'm going to put little circles and boxes around the different points. So I look here, H and H go together, so I'm not going to worry about that. G and K, I'll put little circles around G and K. F and J, I'll put little boxes around them. All right, so my X is right here, so I'm going to put it on top, 2x minus 11. So 2x minus 11 is between H and the circle. So I'm going to look for H and the circle is going to be 33. And then I need to go back to my original triangle, the triangle with the variable. The other side length is 5, so it needs to go on top. And it's between H and the box, so H in the box is 15. All right, that's that. Now we just have to solve. I'm going to start off, I'll just multiply by 33 to start off with. So I've got 2x minus 11 equals, well, what's that fraction over there going to be? 5 over 15 times 33. That is 1 over 3 times 33, which is 11. So I'm going to put 11 there. I add my 11 over, and I get 2x is 22. Divide by 2, and x is 11. There we are. That's our answer. Now, on the homework, there may be problems that are actually a little bit easier than this, but they look different. They're still going to be like solving for a side, but they won't have a variable like this. They'll have a question mark, and it'll count for the whole side. If you see a question mark on one of those problems, just mark it out and put an X, and now the whole side is X. It's actually a little bit easier of a problem whenever you have to go and solve, because this one here you have 2x minus 11. If you just had a plain old x, then what is it? Our last three steps here would have been, they wouldn't have happened. So again, if you see a question mark as a side length, then go ahead and cross that out, put an x, and you solve it the same way as what we're doing right here. All right.